Chapter 12, Problem 8. Here the human circulatory system has approximately 10 to the ninth capillary vessels, each with a diameter of about 8 microns. Assuming cardiac output is 5 liters per minute, determine the average velocity of blood flow through each capillary vessel. So we got 10 to the ninth capillaries, and we've got an 8 micron diameter per capillary. So what is the area per capillary? Area per capillary. All right, pi times 8, 8 times 10 to the minus 6 meters squared, right? So the area per capillary is pi times 8e minus 6 squared. 2.01 times 10 to the minus 10, right? 2.01 times 10 to the minus 10. So 2.0 times 10 to the minus 10 square meters. And so that means the area of the capillaries equals the number, right? Number of caps times the area per capillary is 10 to the ninth capillaries times this 2 times 10 to the minus 10 meters squared, right? And so that's going to give us 0.2 meters squared. All right, 0.2 square meters. Okay. I'm going to back up. I made a mistake. That's a diameter of 8, which means this is a 4 and not an 8, which means that I go here, change that 8 to a 4. I've got 5.02 times 10 to the minus 11. 5 times 10 to the minus 11, which gives us 5 here, 10 to the minus 11 here. All right, and now we're talking about 0.05 square meters. All right, 10 to the minus 2, 5 times 10 to the minus 2, 0.05 square meters. All right, that's it for the first. That gets us to the area of the capillaries. Assuming cardiac output is 5 liters per minute, determine the average velocity of blood flow with each capillary through each capillary vessel. Okay. All right, and I'm going to go ahead and convert this over because it's going to help us in a second. I'm going to convert this over to centimeters, 0.05, right? To get it to centimeters, a meter is 100 centimeters. That's going to be times 10 to the 4, right, to get us to centimeters squared, which gives us 500 centimeters squared, right? Equals 0.05 times 1e4, 500 square centimeters. Yep. All right. So now we've got 5 liters per minute. Determine the velocity of the blood flow. Well, they've given us the flow rate, which is the area times the velocity, right? We have the area, we have the flow rate, and we're looking for the velocity. Velocity equals the flow rate divided by area. So that's 5 liters per minute divided by the area, which is 500 centimeters squared, right? Now, a liter is 1,000 cubic centimeters, so this is 5,000, right? 5,000 cubic centimeters per minute divided by 500 square centimeters, right? And that's going to leave us with 10 centimeters per minute. All right, per minute times a minute per 60 seconds, right? So 10 divided by 60 is 0.167 centimeters per second. 0.167 centimeters per second. And that is the velocity of the blood in the capillaries. And that's it for problem 8.